Let's continue on with some more examples. Suppose that a market research analyst for a cell phone company conducts a study of their customers who exceed the time allowance included on their basic cell phone contract. The analyst finds that for those people who exceed the time included in their basic contract, the excess time used follows an exponential distribution with a mean of 22 minutes. Consider a random sample of 80 customers who exceed the time allowance included in their basic cell phone contract. X will equal the excess time used by one individual cell phone customer who exceeds his contracted time. So first, let's go back and recall that the random variable that follows an exponential function has some decay parameter, and m is found, so this is the decay parameter, and we find it with 1 divided by the mean. And we know that the mean here they gave us as 22, so our decay parameter is 1 over 22 here. We also know in an exponential distribution that the mean equals the standard deviation. So that means the standard deviation is also 22. So A says, find the probability that the mean excess time used by the 80 customers in the sample is longer than 20 minutes. This is asking us to find the probability that the mean excess time is greater than 20. Draw the graph. So the first thing we want to do, it's the mean. So we are going to use X, this distribution. We know that our mean is 22. We know that our standard deviation is also 22, and our sample is 80. Now we can go ahead and use the normal distribution, or the normal CDF. 20 is our lower value, right? Greater than 20. So 20 is the lower value. E99 for the upper limit, 22 for our mean, and 22 over square root of 80. I've already calculated this in my calculator. It's 79.19, so that means there is a 79.19% probability that the mean excess time used by the 80 customers is longer than 20 minutes. So the mean excess time greater than 20 minutes, there's a 79.19% chance. Now if we sketch this, our mean is at 22. This looked at greater than 20, so this was the probability that it was greater than 20 minutes. So there's our graph. All right, for B, it says suppose that one customer who exceeds the time limit for his cell phone contract is randomly selected. Find the probability that this individual customer's excess time is longer than 20 minutes. This is asking to find the probability of an individual greater than 20 minutes. So because it's an individual, we are not going to use CLT. We are going to use the exponential distribution, and this is in MX. This is what we will be using to calculate this, and we will just replace M, which we have up here is 1 over 22, times X. Our X value in this case is 20. You put this in your calculator. We do have a button e to the x here, so second e to the x. I'm going to use parentheses -1 divided by 22, close parentheses, times 20, close that parentheses, and I get 0.4028, or a 40.28% probability that one customer randomly selected will exceed his contract longer than 20 minutes. C says, explain why the probabilities in parts A and B are different. There's a couple reasons here why they're different, and to me they seem pretty obvious. Hopefully to you they seem pretty obvious. A, we are looking at the mean, so we are taking the average of all of these 80 customers. B is just one customer. Also, we're using different distributions. So we used different distributions to calculate probabilities for an individual and for means. So that's why they're different. Using the CLT to find percentiles. Find the 95th percentile for the sample mean, access time for samples of 80 customers who exceed their basic contract, time allowances, draw a graph. So 95th, and it's a sample mean. So we are going to use K is the 95th percentile, where this is where we've got that set up. So we are going to use the inverse norm, 0.95. We are going to use 22. We're going to use 22 divided by the square root of 80. I already calculated this in my calculator, which we are all becoming professionals at. I get 26. So what this means is that 95% of the samples have means less than 26 minutes. So 95% of the people go over less than 26 minutes. And if we sketch a graph of our distribution, some K value, which we calculated to be 26, so less than, so this is 95%.